So our next topic is about 1 over m monthly annuities. That means a unit 1 over m annuity makes a payment of 1 over m at the beginning for due or end for immediate of each 1 over m years. Most retirement annuities make monthly payments, so 1 over 12 annuities are common, and actuarial notation has a superscript m for a and double dot a to indicate that this is an 1 over monthly annuity. For the corresponding, let's say, AX here and a capital X here, the monthly annuities will be M to the superscript here and here. And that means 1 minus A superscript M over D superscript M. And AX will be here AX to the superscript M, D to the superscript M, and AX to the superscript M. So the translations of these kind of formulas is very common. And last lecture we have been solving task on 1 over monthly annuity correspondingly to financial applications, and now let's solve another task for annuity corresponding to life application. So for a life annuity age 40, this is the task number 6, we are given these values. So y is the present value random variable for an annuity that pays 100 every 6 months starting immediately. We have got the mortality rate, and we have got delta equals 0.07. So our answer is to just apply the formula, and let me impute the formula. So our task 6, the imputed formula will be double dot a x to the power m. This will be the sum for k equals 0 to infinity. Okay, let that be infinity. Fraction 1 over m v to the power of k over m, and there will be also the superscript k over m, which goes below to the subscript. How to be? Let me distinguish by multiplication, px, like that. So this is our formula for whole life 1 over monthly annuity due, and this is the formula for the expected value. And now we're ready to impute the values as given in our task, and that means our double dot axm will be, for x we just put 14, here we put 2, like that, and our sum will be transformed k from 0 to infinity. Let me again try to infinity. So 1 over m, that means we have here 1 over 2. Then v to the power of km. We have to distinguish what will be the m. V to the power of km, this can be distinguished as exponent. Exponent to the power of delta is given, which is delta equals 0.07, and we can place here as minus 0.07 times k over 2. And next, this value will be the exponent to the power of minus 0.005, which is given again in our task for practice 6, this value. If t is more than 0, that means here we place k again and over 2. So this kind of formula we applied. Our v, km and kmpx are transformed. Kmpx transformed because we have the mortality rate given, and v to the power of km, we just expected that our exponent will be okay to be placed here. So that value generally can be transformed to the fraction, and the fraction will have this 1 minus exponent to the power of minus 0.0375, and we have to compute. So 0.0375 is just those values calculated and multiplied, and 1 minus 2 to the power of 1 minus exponent to the power of minus 0.0375. So we just replaced the power to allow us to calculate the exponent as the function, exponent of x. So once we implied everything here, we have this initially A42, which is 13.5849, and the expectation here will be as given in our practice, so that we pay 100 every 6 months. That means we have to multiply to 200. So the answer will be 200 times this value, and this will be 2716.98. So this is it for our discrete values, and for our continuous values we can refer to our handout. In the handout there are formula for continuous cases, and these kind of formulas for continuous cases, just like the previous two